In this video, we'll look at question 52 from the 2016 exam. So in this question, a spacecraft is going from the Earth to the Moon, but halfway through they realize that they don't have enough speed, or they'd like to go faster. So they eject some fuel all of a sudden in a massive burst to propel themselves forwards. And their speed increases by a bit, but they lose a mass m of fuel which goes away at 1,425 meters per second relative to the rocket, obviously in the other direction as to increase the speed. And our task is to find the mass of the fuel ejected. And whenever we see anything to do with the rockets, really, objects being propelled, speeds and masses, we should think in terms of momentum and conservation of momentum. And the momentum before this burst will be just the speed times mass, 7,425 meters per second times 4,000 kilograms, which gives us this amount of momentum, kilogram meter per second. Before we start calculating the momentum after the burst, we should think carefully about the speed. Because in the question they clearly say that it goes away at 1,425 meters per second with respect to the rocket, not the free space. So in fact, as seen from, say, the Earth or the Moon, the speed of the mass will be forwards of magnitude 7,425, the speed of the rocket, minus what it observes, like this, and that gives us 6,000 meters per second. So an astronaut inside the spacecraft would say that the fuel is moving away from him at this speed, but what an observer on Earth would see is fuel coming off, but still moving in the forwards direction, but with a much slower speed than the rocket itself. So now the momentum of just the rocket after the burst is its new speed times new mass, which is 4,000, minus mass m, which now it has ejected, plus 6,000, the speed of the fuel in our stationary frame, times the mass m. And now finally comes the time when we can set the two momenta equal to one another by conservation of momentum, which when you distribute these brackets here, gives us a linear equation in m, which after rearrangement gives us 300,000 equals 1,500 m, and so the mass of the ejected fuel must be 200 kilograms. And that is the final answer to this question, and in the exam it was option E.